First of all, thank you very much for the organizers to invite me here and to present our point of view from microgrids to grid-scale storage, different applications for battery energy storage systems. A few words very shortly to me. I work for Younicos in Germany, and we are one of the global leaders for the control software and the integration of components to storage systems. Our expertise is like the overall design of these systems, the selection of the components, the sizing of the system, and how to combine the whole thing with a smart software and hardware control to a working application. We have installations all over the world, 95 megawatts in total until now. As you can see, India is missing, and so I'm excited to be here. To look at applications, definitely one application are microgrids, and we are currently building a microgrid on the island of Graciosa. This is an island in the Atlantic, in the Azores, the island shown on this picture. And here the renewable share was locked down to definitely under 10%. And why was this? The reason is that the diesel generator on that island provides a heartbeat of the system. And if you put in more and more renewables, they can't be used, they have to be curtailed because the heartbeat of the diesel needs to run all the times. And this limits the renewable share well below 10%. By putting in a 3 megawatt battery system and building 5 wind turbines with nearly 4.5 megawatt in total, we can unlock this barrier. The battery starts taking over the system services that are critical. The battery is providing frequency control, voltage control, short circuit power, and other services. So most of the time, more than 50% of the year, the diesel power plant will be completely switched off. The system will be run with the heartbeat of the grid-forming battery storage, and on top, the kilowatt hours will be supplied by the wind turbines and the solar installations integrated. And to look at the commercial point of view, this system is today cheaper than the diesel generation on that island. That means we have a positive business case from year one, and looking at the energy or the price increase of diesel, not in the last 6 weeks, not in the last 1 year, but on long term, on the last 20, 30 years, if we anticipate that, the system has a huge benefit. And now looking in the introduction of this session, it was said the moody energy of renewables, wind and solar. Battery storage is one way to tame them, and this allows us an epochal shift, namely to leave the carbon dioxide producing energy sector and go to a carbon less or carbon avoiding energy production. And therefore we have this sign in front of our tech center in Berlin, Berlin, the city with the sector. So you're leaving the CO2 producing sector in our tech center. What does it mean? This is a problem we face in Germany with the energy transition and the moody renewables. We get more and more renewables, which is positive because they phase out natural gas, lignite, and other conventional generation. But on the other side, we get a lack of system services. The system services will be the system constraint, and that's what the speaker before mentioned, the primary frequency control services. And if we don't have these services, the quality of supply is in risk, and we might face blackouts. And during the last solar eclipse, it was heavily discussed in Germany if the gradient of the PV ramping up when the sun... no, it's fine, that's my slide. That this might give us a blackout in the power system. And what we need is batteries, because batteries are very fast and very precise. So they are, in a way, the master of the renewables. They are the key component that helps us tame renewables and use them and integrate them. And on the list shown before, the plants in Germany, The 1.2 megawatt is our technology center using sodium, sulfur, and lithium ion since 2012 for frequency control. It was the first installation that was providing that service from batteries in Germany. And this battery power plant is a bit outside of Berlin. It's a 5 megawatt plant. The footprint is about 20 times 20 meters. And it provides frequency control on a commercial basis. So it's not a subsidized system. It's working on that market incentive itself. And it is filled up with 2 floors of racks, in this case Samsung lithium-ion batteries, the cells packaged in trays, packaged in these racks. So to wrap up, because my time is nearly over, I'm happy to be here. Battery storage can help us unlock a set of barriers in small system, in residential or commercial applications where power quality or interruptible power supply is a key issue. It can help us island microgrids or village microgrids and help us substituting diesel in remote areas and provide a much higher service and quality of supply. But battery storage can scale up to multi-megawatt installations. The largest battery plant we have in Texas is 36 megawatt on one side. So the technology scales up from a few kilowatts, 100 kilowatts, up to multiple tens of megawatts, is cost competitive, provides services cheaper than conventional generators. And therefore, I'm very happy to announce also that for the Indian market, as you've seen, it's a white spot on our map until now, that we will cooperate with Global Energy to bring this technology to the market here. Thank you very much for your attention, and I'm looking forward to the discussion. Thank you.